Hey everyone, this is Bhargav Suthar, and today we are going to learn how to find a transitive closure by the conventional method. Okay, so we'll discuss transitive closure and some of the examples by the conventional method. So first, let us understand what is a transitive closure. Now we all know that what is a transitive relation. Okay, so the transitive closure of a relation R is the smallest transitive relation containing the given relation R. Okay, again I'm repeating, it is a relation and it is the smallest relation containing, and it has to be a transitive relation. So smallest transitive relation containing R. So the transitive closure, it is denoted by the symbol R star. Now to find the transitive closure, so first let capital A be a set and cardinality of A is n. Now what does that mean? Now cardinality of A, that means the number of elements in the given set. So that is, so modulus of A, it is denoted by this modulus of A equals to n. So let us consider a set A and it has the cardinality n. So that means the number of elements are n. Now let capital R be a relation on A. Then this R star equals to, it is defined as like this, R union R square union R cube up to union R raised to n, whatever the cardinality of A is. Now where this R square is R dot R, now we know that what is R dot R, it is a composition of a relation that we discussed earlier. Okay, so R square equals to R dot R, then in same manner R cube equals to R dot R dot R, or simply R into R square. So that is composition of a relation R and R square, and so on. So let us discuss example. Now the question is, if A equals to 1, 2, 3, the given set is 1, 2, 3 and MR. Now what is MR? It is a matrix of relation, or in short it is a relation matrix, and that is given as 1, 0, 1, 0, 1, 0 and 1, 1, 0. Now find its transitive closure. Now the solution. So first of all, let us calculate R using the relation matrix. Here we have given the relation matrix, so using that we will write what is a relation and then we'll proceed further. So what will be the relation? It will be like this. See, we have A equals to 1, 2, 3, so and it is the same set, so that means it is a relation on A. So the matrix contains 3 rows, 3 columns. So first column, second column and third column represent 1, 2, 3, and same way first row, second row and third row represent 1, 2, 3. Now the one entry means what? 1 is related to 1, now second is 0, now third. So that means it is in which position? It is in first row and third column. So that means 1, 3. So 1, 3 will be there. Now just come to the second row. So in second row and second column, so 1 is there, so 2, 2 will be there. Now come to third row and first column. So third row, first column, so that is 1. So that means 3, 1, and in same manner 3, 2. So in relation 1, 1, 1, 3, 2, 2, 3, 1, 3, 2. This many entries will be there. So this is the relation. Now we want to find a transitive closure, and that is the smallest transitive relation containing the R. So let R star be a transitive closure of R. So here this cardinality of A, the cardinality of given set is 3. Okay, so how to define R star? So R star will be this R union R square up to, by the definition, up to R raised to n, but here n is 3, so R union R square union R cube. So this will be the R star. So all we need to find, that is R, that is already we have found. Now R square and R cube, then we will take the union and then we are through. So here we have R equals to this, that is 1, 1, 1, 3, 2, 2, 3, 1 and 3, 2. Now we will find R square. So R square is R dot R. Now how to calculate R square? Now see, it is a composition of R with itself, so R square. Now see, consider in R 1 is related to 1. Now again 1 is related to 1, so 1, 1 entry will be there. Now same way 1 is related to 1 and 1 is related to 3, so 1, 3 pair will be there. Now done. Now 2 is related to 2 and 2 is related to itself, so 2, 2 pair will be there. Now then 3 is related to 1 and 1 is related to 1, so 3, 1 pair will be there. And in same manner 3 is related to 1 and 1 is related to 3. So 3 3 pair will be there, and in last 3 is related to 2 and 2 is related to 2. So 3 2 pair will be there. So this is how you can calculate this. Now we have already discussed this composition in our previous lecture very thoroughly. So next, R cube. So that is R and R square. So now consider R and R square. Now 1 is related to 1 and 1 is related to 1. So 1 1 pair will be there. Now 1 is related to 1 and in R square 1 is related to 3. So 1 1 1 3. So 1 3 pair will be there. Now 1 is related to 1 and 1 is related to 2 in R square. So 1 1 1 2. So 1 2 will be there. Now next, 1 3 and 3 is related to 1, 3 is related to 3 and 3 is related to 2. So 1 1 1 3 and 1 2. That pair, they are same. So as it is a set, we will have unique elements. So that's it. Then 2 is related to 2. Now in R square 2 is related to 2. So 2 2 pair will be there. Now 3 is related to 1 and in R square 1 is related to 1, 3 and 2. So 3 1, 3 2 and 3 3. 3 1 3 2 3 3 pair will be there. So that's it. Now then 3 2. So 3 2 and in R square 2 is related to 2. So 3 2. So that is also there. So this is how you can calculate R cube. Now here R star. What is R star? It is the union of all these three, that is R, R square and R cube. So if you take the union, then you will get this R star. So this is the final answer. So this is the smallest transitive relation containing R. So if you want to check whether it is a transitive relation, you can check it. See, 1 is related to 2, then 2 is related to any point? No, so that's it. Now 3 is related to 4, then 4 is related to 5. So what is a transitive relation? If A is related to B, B is related to C, then A has to be related to C. So here 3 is related to 4, 4 is related to 5. So then 3 and 5 pair must be there in the R star because it is the smallest and it is the transitive relation. So 3 4 4 5. So 3 5. Is 3 5 pair there? Yes, it is there. 3 5. Now 1 is related to 2 and 4 is related to 2. So 1 2 pair will be there. Yes, it is there. So this is how you can calculate. Let us take another example. So if A equals to 1 2 3 4 5 and R equals to 1 2 3 4 4 5 4 1 and 1 1, it is given. So find its transitive closure. So here directly we have given R. Okay. So in previous example it was the relation matrix and after that we wrote R. So here there is no need to do that. So now R star. So let R star be the transitive closure of R. So here the cardinality of A, that means how many points or how many elements are there in A. So it is clear there are 5. So what will be the R star? It will be R union R square union R cube union R raised to 4 and union R raised to 5. So this will be the R star, that is the transitive closure. So here we have R equals to this. So now all we need to find is R square, R cube, R raised to 4 and R raised to 5. So R square will be like this. So how is calculated? So 1 is related to 2. See, in R consider 1 2. 1 is related to 2. Now in same R 2 is related to which point? 2 is related to nothing. So that's it. Just ignore that point. Now 3 is related to 4 and 4 is related to 5. So 3 5 pair will be there. So 3 5. Now next 3 is related to 4 and 4 is related to 1 also. So 3 4 4 1. So 3 1 pair will be there like this. Now consider 4 5. Now 4 is related to 5 but 5 is related to some point. No. So just ignore that. Now 4 is related to 1 and 1 is related to 1. So 4 1 will be there. Now next 4 is related to 1 and 1 is related to 2. So 4 2 pair will be there. And last 1 is related to 1 and 1 is related to 2. So 1 1 and also 1 is related to 1, 1 is related to 1. So 1 1 and next last 1 is related to 1 and 1 is related to 2. So 1 2 pair will be there. So this is how you can calculate R square. So now next R cube. So that is R and composition R square. So we will have to consider the points of R and points of R square. Okay. So if you find this, you will get the answer 3 2 3 1 4 1 4 2 1 1 and 1 2. And in same manner you will get R raised to 4, that is R composition R cube, and also in same manner you will get R raised to 5, so that is R composition R raised to 4. So So the final answer will be like this. So hence R star will be this. So if you take union of all these answers, that is R, R square, R cube, R raised to 4 and R raised to 5, you will get this answer. Now this is the transitive closure, and it is the smallest transitive relation containing the given relation R. Now you can check that it is a transitive relation. How? See, now 3 is related to 4 and 4 is related to 5. What we need to check for transitive relation, if A is related to B, B is related to C, then A has to be related to C. So as you can see that 3 is related to 4 and 4 is related to 5. So 3-5 pair has to be there. So is 3-5 pair there? Yes, it is there. So this is how you can check for each and every pair, and it will be true. Thank you.